here we have a type called point with 3 members x, y, and z of type number. We will have lots of points in our application, and one such point is the special variable called center. The reason why center is a bit special is because we want this to be immutable. We don't want anybody changing its x, y, or z values. So if anyone tries to assign some value to center.x, we want this to be a compiler error. Now we can achieve that quite easily by creating this type called read-only-point, which has the same members as point, except that all of those members are marked as read-only, and then use this type specifically for the center variable. And now we get a nice error if anybody tries to assign to these members, for example the x member. However, notice the code duplication between point and read-only-point. We can get rid of this duplication by using mapped types. A mapped type consists of 3 key portions: a loop variable, a union of types that we are going to loop over, and an output type. In our case, we can loop over the union of keys x, y, and z. And for the output, we know that all of these members need to be of type number, so we use the type number. We don't have the need for a loop variable yet, so we leave it as it is. And with that, you've successfully created your first mapped type. Now right now, this read-only point is exactly the same as the type point. The great thing about map types is that you can add modifiers that will apply to all the loop items. So if we apply the modifier read-only, all of these members become read-only, which is the type that we want to generate. Now let's apply other features from TypeScript to clean this code up a bit more. Instead of hand coding this union of strings, we can generate it by applying the key-of operator to the point type. Additionally, instead of assuming that all of these members need to be of type number, we can read the type of the individual members by using the loop variable to look up the type of the member from point. As a final step, we can create a utility type function by taking a generic argument of type t and using that instead of the hard-coded point type. And now we can use it to create read-only versions of any input type, and for our particular case, our input type will be the type point. And at this juncture, I'm actually happy to inform you that you don't need to create this particular read-only utility type. It comes baked in as a part of the TypeScript compiler, and if we delete our custom implementation, it falls back to that one, and the internal implementation has been coded up exactly how we did it right now. Now with this annotation in place, TypeScript correctly points out any invalid usages of center, and we can go ahead and fix those.